Let's evaluate the integral of x cubed times the natural log of x quantity squared. First, note that ln of x quantity squared does not equal to, it is not the same thing as ln of x squared. This part on the right would be nice if that was true, but it isn't. That part on the right equals to 2 times natural log of x, but not the part on the left. So we can't do anything with the natural log of x squared part. We're going to use integration by parts. And let's recall where that comes from. In Calculus 1, you learned that the derivative of a product of two functions is first times the derivative of the second. I'm calling the derivative of the second dv plus the second v times the derivative of the first, which is du. If I integrate both sides, so the integral of the derivative of the product is equal to the integral of u dv plus the integral of v du. By fundamental theorem of calculus, this left-hand side is just u times v, and the right is the integral of u dv plus the integral of v du. And I'm going to solve for the integral of u dv. It's u times v minus the integral of v du. This is integration by parts formula. The idea is to let the difficult integral, the one we're starting with, equal to the left-hand side, call part of the integral u, the rest dv. From there we can find du and hopefully find v, and then express the integral on the left in terms of what you have on the right. U times v, there's nothing to integrate, and then minus the integral of v du. And we hope that the integral of v du is a lot easier than the integral of u dv. So let's bring in our integral, that is x cubed times the ln of x quantity squared. The rule of thumb is, doesn't always work, but it works most of the time. If you have a natural log somehow involved in an integral, and we're using integration by parts, is to let u be the natural log part. In this case, it's ln of x quantity squared. And let dv be the rest, which is x cubed dx. Now, it may not work, and you'll soon enough realize that, but at least from here we can proceed further. The derivative of u is 2 ln of x times 1 over x dx. And the antiderivative of dv, that is v, is, we can take any antiderivative of x cubed. Let's take just the one with the constant of integration be 0. So it's 1/4 x to the 4th. Now let's use the integration by parts formula. Here's our integral, x cubed times ln of x quantity squared dx. We're calling all of this u dv. This is equal to u times v. I'll write it as v times u. It's easier to see express. 1/4 x to the 4th ln of x quantity squared. So there's nothing to integrate here. This part is finished. Let's call this u times v minus the integral of v du. So right over here is v, and this is du. Let's multiply. 1/4 times 2 is 1/2, so we have a half out here. And then we have x to the 4th and natural log of x and 1 over x dx. So this right here, all of this is the integral of v du. Let me simplify it. This is equal to 1/4 x to the 4th times natural log of x quantity squared minus 1/2 times the integral x to the 4th over x is x cubed, and then ln of x dx. So what we have left, we look at the integral on the left and the integral on the right. We're not done yet, but the integral on the right is easier to handle than the integral on the left. We're going to have to use integration by parts one more time to finish the problem. I'm circling this integral without the half. We'll come back once we have a solution. We'll multiply it by 1/2. So I'm going to separately now do integration by parts on this circled integral. Here's the integral, x cubed ln of x dx. U, of course, still will be the natural log part, that's ln of x. Du 1 over x dx. dv x cubed dx. v 1/4 x to the 4th. So this integral equals u times v, 1/4 x to the 4th times ln of x minus the integral of v du. So v is 1/4 x to the 4th, du is 1 over x. That's going to be 1/4 x cubed dx. And see, this integral now on the right is very doable, very easy. So we get 1/4 x to the 4th ln of x minus 1/16 x to the 4th. And now we're ready to finally put everything together for our solution to this problem. Let me write this over here. So our original integral was x cubed times ln of x quantity squared dx. Now in the first iteration of integration by parts, we ended up with 1/4 x to the 4th times ln of x squared minus the integral 1/2, this part 1/2 times the integral of x cubed times ln of x dx. The second iteration yielded the following. So we still have 1/4 x to the 4th times ln of x squared minus 1/2 times the second integral, and the second integral came out to be 1/4 x to the 4th ln of x minus 1 over 16 x to the 4th. Now we can add a c at the end. Don't have to multiply c by anything. C is always added at the end. And let's simplify this just a bit to get the final answer. The final answer is 1/4 x to the 4th times ln of x squared minus 1 over 8 x to the 4th times ln of x plus 1 divided by 32 x to the 4th, and then add c at the end. Now we can, if we want to, factor out x to the 4th. As you can see, all three parts have